A common struggle in the first unit of Calculus 2 is figuring out when to use which integration method. So we're going to do a quick overview of what to look for to help you decide which method you should be using. We've got 4 techniques that we're learning in this unit: integration by parts, trig identities, trig substitution, and partial fraction decomposition. And let's take a first look at the first one, integration by parts. First and foremost, I'm usually looking for a product of functions. I'm looking for 2 things that are multiplying by each other to make integration by parts work. It might be a common temptation to try and split this up into 2 separate integrals, but you can only do that if it's adding or subtracting 2 functions or expressions. Here, if it's a product, you're going to use integration by parts. Another time that I might use this is with some sticky functions like logs or inverse trig functions. This is a great method to integrate those. With trig identities, I'm looking for powers of tangent and secant multiplying by each other, or powers of sine and cosine multiplying by each other. A third option is even powers of these trig functions. With trig substitution, really I'm looking for something that contains an x squared minus a number, x squared plus a number, or a number minus x squared. If I see that in there, then I start thinking trig substitution. Most of the time we want to see a square root in there, but it isn't necessary. You can have other powers. For example, a 3/2 power, or even just to the third power, we can often get this method to work. I also don't have to have just an x squared in there. There could be a number multiplying by that x squared, and this method will still work. And a less commonly seen option, but still a possibility, is irreducible polynomials in the denominator. If I cannot factor the denominator, I could complete the square and turn this into something that looks like an x squared plus or minus a number or so on by doing a u substitution. Not commonly seen, probably won't see one of that level of difficulty on an exam. And the last one is partial fraction decomposition. I'm looking for a polynomial in the denominator that is factorable. Okay, I need to be able to break it up into discrete factors. This middle one here is an example of something that I could factor. And it doesn't have to be completely factorable. You can have some irreducible factors in here. And actually, that should be a +1 to make this irreducible. If this was x squared plus 1, that's still okay. As long as something was able to be factored out, then I can use a partial fraction decomposition here. Well, I hope that quick overview helped you to identify when to use which of those 4 methods for our Unit 1 exam.